Okay, hello everyone. Okay, so the next program in chapter 3 is roulette wheel colors. So on a roulette wheel, the pockets are numbered from 0 to 36. The colors of the pockets are as follows. Pocket 0 is green. For pockets 1 through 10, the odd numbered pockets are red and the even numbered pockets are black. For pockets 11 through 18, the odd numbered pockets are black and the even numbered pockets are red. For pockets 19 through 28, the odd numbered pockets are red and the even numbered pockets are black. And then the last one for pockets 26 through 36, the odd numbered pockets are black and the even numbered pockets are red. So write a program that asks the user to enter a pocket number and displays whether the pocket is green, red, or black. The program should display an error message if the user enters a number that is outside the range of 0 through 36. Okay, so basically, the user is going to enter a number. The program is going to ask the user to enter a number, okay, which is going to be a pocket number, and it's going to display whether the pocket is green, red, or black. So that's the only colors of the pocket, all right? Those are the only colors of the pockets, and it's going to be the green, red, or black based on on these numbers that based on these scenarios, based on the numbers that are given here. So we'll go through them whilst we're writing the program. But also the program should display an error message if the user enters a number that is outside the range of 0 through 36. So that's just an input validation issue. So we'll do that as we get to that point. All right, so I'll go ahead and start. So the program says, the question says, write a program that asks the user to enter a pocket number and displays. Okay, so the program is first going to ask the user for a pocket number. So let's go ahead and do that. Let's go ahead and use the input function to ask the user to enter a pocket number, right? So I'm going to call the input function, and I'm going to say, please enter a pocket number, right? And anything that anything that the input function returns is a string, right? So even if the user types in a number, that number is going to be returned as a string. And we can't use strings in calculations. In this case, we're not really doing any calculation, but we can't really use strings in the way we want to use it here. So we need that input that the user has typed as an integer so we can manipulate or work with it. But the way it stands, the input function is going to return a string. So because we want it as an integer, we need to convert that string to an integer. Okay, and the input function always returns a string. So I'm going to go ahead and convert everything that the user has typed into an integer by calling the int function and surrounding everything that the user has typed with parentheses. So I'm converting everything that the user has typed over here to an integer, okay? And once I do that, I need a place to store it. So I'm going to go ahead and create a variable. I'm going to call it user pockets number. Okay, user pockets number is now going to be called to what the user has typed converted to an integer, and it's going to be stored in user pockets number. So now we have the user pockets number, so we can go ahead and test on this user pocket number, right? So I'm going to go ahead and before that, the question says, or the program says, the colors of the pockets are as follows. Pocket 0 is green, all right? So if the user pocket number is 0, then let's display the pocket is green. So because the question over here says this, if the users, the program should display an before that, it's going to display whether the pocket is green, red, or black based on all the stuff given here. So we're going to just display, if the pocket number is 0, we're going to display green, all right? So let's start with that. Let's start with 0. So let's say if, but before that, let's work on the input validation. The reason why I'm saying is just work on input validation. It's going to be easier that way, so that we can rule out any number that's outside of this range whilst we are creating that if elif block. Okay, so let's work on the input validation. The program says that the question says the program should display an error message if the user enters a number that is outside the range of 0 through 36, right? So anything outside the range of 0 through 36 is out. It's not part of it. The program should display an error message. So anything less than 0, okay, or anything greater than 36 is not part. It's not a valid number. So let's create an if statement here, and I'm going to say if, okay, I'm going to say if the user pocket number, okay, is less than 0. Okay, that's the first one. That's the first condition. If the user pocket number is less than 0, okay, I'm going to call the OR keyword. So OR user pocket number is greater than 36. So meaning, if any of these is true, if user pocket number is less than 0, okay, if that is true, then it's going to do what's in this if block. Or if user pocket number is greater than 36, then it's going to do what's in this block. All it needs is for one of these to be true. If this is true, if user pocket number less than 0 is true, it's going to do what's in the if block. If user pocket number is greater than 36, it's going to do what's in the if block. If both of them are true, it's going to do what's in the if block. All it needs is at least one of them to be true. So if that's the case, then we want to go ahead and display a message. So I'm going to call the print function and display a message and say no semicolon. No semicolon. I'm going to print a message and say, please enter a number in the range of 0 to 36, right? 0. Let's see. Yeah. Please enter the number in the range of 0 to 36, right? I'll just say this, to 36. Okay, and a number from, let's just say from 0 to 36. Okay, so that's what we're going to print, right? So now we are sure that after this block, or after this if statement runs, we are sure that we are going to the program is going to display an error message, right? All right, so if this is the case, it's going to print, please enter a number from 0 to 36, right? Now, what if that's not the case? What if that number is not less than 0 or not greater than 36? And that means it's valid. So we want to use it. So I'm going to go ahead and call an else statement. And that's where we start. So else meaning that the number is valid. If it's valid, then let's go ahead and check to see if the number is any of these, and then display the right color of the pocket. So if that number is not less than 0 or not greater than 36, then that number is within this range. So then that number is from 0 to 36, right? So let's check on those numbers and see like exactly what range they fall in, so we can know the color of the pocket. So let's start with 0. So else, in that else block, I'm going to create an if statement and say if the user pocket number is equal to, okay, double equal to 0. Okay, now when I use double equals to, I'm comparing. If I use 1 equal to, I am assigning 0 to user pocket. But over here, I'm using double equal to, meaning I'm just comparing 0 to what's the value of user pocket number. So if this is the case, if user pocket number is equal to 0, then I'm going to print. Okay, I'm going to just create a print statement here. I can just type it. Actually, I don't know. I'm just being all right. I'm going to print the pocket is green, because over here, if the pocket is 0, then the pocket is green. Pocket 0 is green. So the pocket is equal to 0, then the pocket is green. Okay, so if the pocket is not 0, right? But before that, we've ruled out anything less than 0, anything greater than 36. So we know we are working with the numbers 0 to 36. And we know that if it's 0, then then the pocket is green. If it's not 0, then that means we are now working with numbers from 1 to 36, right? We know we're now working from numbers 1 to 36. So let's move on. Over here it says for pockets 1 through 10. Okay, the odd numbered pockets are red and the even numbered pockets are black. Now there's a way to figure out if a number is odd or if the number is even. But now if this is not the case, if user pocket number is not equal to 0, then we know we're working with numbers from 1 to 36, right? And over here it's saying for pockets 1 through 10, right? So this is what I'm going to do. I'm going to, in this if block, if user pocket number is not equal to 0. If it's not equal to 0, okay, so I'm going to create an else if here. I mean, not else if, elif. Else if is equivalent in other languages. So elif. Oops, sorry. I'm not supposed to create it there. So forgive me there. All right. So think about it. Actually, I'm supposed to create it there because like I was explaining before, I thought I was working in a different block. All right. So if the number is not equal to 0, then that means that we are working with numbers from 1 to 36. All right. So elif. All right. User pocket number. But I'm going to say is less than 11, right? And I'll explain. So over here, we ruled out that the number is not less than 0, it's not less than 36. We know we're working with numbers 0 to 36, right? Over here, if the number is not equal to 0, then we're working with numbers from 1 to 36. And if you're working for numbers 1 to 36, right? Over here, if that range, we are working from numbers 1 to 36, right? But we want the numbers from 1 to 36 that are also less than 11, which gives us 1 to 10. All right, so if the user pocket number is less than 11, meaning from 1 to 10, all right, from 1 to 10, and that's what we have here. For pockets 1 through 10, the odd numbered pockets are red and the even numbered pockets are black. So let's figure out in this block. We've been able to narrow it down over here to 1 to 10. The numbers 1 to 10. So let's check the numbers 1 to 10 to see which ones are odd, which ones are even. Okay. I mean, let's determine that if that number is in that range 1 to 10, let's determine if that number is odd or that number is even. So in that elif block, all right, or in that elif block, I'm going to create another if statement, and this one is just going to check to see if that number is odd or even. So I'm going to say if user pocket number, okay, modulus 2 is equal to, again, I'm using double equals, is equal to 0, and I'll explain why. Let me pull the calculator in a second. All right, just a second to explain. The modulo sign returns a remainder. Okay, so if I do 2 divided by 1, I'm sorry, not 2 divided by 1, 2 divided by 2, I get 1. That's 2 divided by 2, I get 1. So that's just division. If I do 10 divided by 2, I get 5. Okay, I get no remainder at the end. 5 remainder 0. If I do 3 divided by 2, I get 1.5, right? So there's a remainder at the end, right? If I do, let's say, 5 divided by 2, I get 2.5, right? I get 2 and then a remainder of 0.5. So anytime you basically divide an even number by 2, you always get a remainder of 0. So let's say 2 is an even number divided by 2, I get 1 remainder 0. Okay, anytime you always get a remainder of 0. If you divide 4 divided by 2, you get a clean number 2 with no remainder. If I do 8 divided by 2, I get 4 with no remainder. But if I divide an odd number by 2, I always get a remainder at the end. So let's say 3 divided by 2, like I did, I get 1.5, and 0.5 being my remainder. If I do 7 divided by 2, I get 3.5, 0.5 being my remainder. 9 divided by 2, I get 4.5, 0.5 being my remainder. So that's how we can check to see if that number is odd or even, right? So over here, we've been able to narrow the numbers down from 1 to 10. So that means that if the program gets to this point, that means that number is between 1 and 10. And we want to check to see if that number between 1 and 10 is an even number or an odd number. And one way to check to see if it's even is this. But I'm not going to start with even yet. I'm going to start with odd. Because the program states it that way. It said for pockets 1 through 10, we've already narrowed it down to 1 through 10. The odd numbered pockets are red. So let's start with the odd numbered pockets. And the way we check to see if that number is odd is this. If you use a pocket number modulus 2, now modulus returns the remainder. Okay, if you divide 5 by 2, it's not going to give you the division 2.5. It's going to give you the remainder after dividing. For example, if you divide 3.2, right? If you divide 3 divided by 2, you get 1.5. It's not going to return the 1, it's going to return the 0.5. It always returns the remainder. All right, so one way to check to see if a number is odd is if it returns your remainder. If that remainder is not, if that remainder is not 0, all right, if it's not 0, then that means that number is odd. Okay, because any odd number you divide by 2 gives you a remainder, and that remainder is not 0. But if you divide an even number by 2, you always get a remainder of 0. So if that number or that remainder that that remainder is 0, then that means that number is even. All right. If you divide a number by 2 and you get a remainder of 0, then that means that number is even. Right. So in this case, we're testing to see if the number is odd first, and after that we check to see if it's even, because the program starts like that. The program says for pockets 1 through 10, we've already narrowed it down to 1 through 10. The odd numbered pockets are red and the even numbered pockets are black. So let's try to see let's try to check for the odd numbered pockets. You have to see if it's odd, if the number is an odd number. So if you use a pocket number modulus 2, meaning if you divide that number by 2 and it gives you a remainder. So the modulus returns always gives you the remainder as an answer. That's why we're using modulus. So if you use a pocket number divided by 2, okay, you can think of it as divided by 2, gives you a remainder, right? But it's not division, it's the modulus, right? So if you use a pocket number modulus 2, gives you, okay, it's equal to a remainder of, that's for even. That's if even. If it gives you a remainder of 0, then that's an even number. But we want to check for odd number first. So if you use a pocket number modulus 2 does not equal to 0. Okay, the exclamation sign over here means does not. All right, so does not equal to 0. And any time you divide an odd number by 2, it does not equal to 0. So if that using the pocket number modulus 2 does not give you a remainder of 0, then that means that number is odd, right? And if that number gives you a remainder of 0, then that means if that number modulus 2 gives you a remainder of 0, then that means that number is even, right? So if the user pocket number modulus 2 does not give you a remainder of 0, that means it's odd. So in that case, we want to go ahead and print what the program says. It says for pockets 1 through 10, the odd numbered pockets are red. So in that case, let's go ahead and print. I think I have it pasted. Yeah, I have it pasted. All right, so undo that. I have it pasted. In that case, let's go ahead and print. Now, please enter, but let me go ahead and print this just so it's easy. In that case, let's go ahead and print the pocket is. Okay, so for 1 through 10, the odd numbered pockets are red. The pocket is red. All right. Now I'm going to call an else. Else meaning that. Right? Else meaning that. Meaning that. So over here, if the user pocket number modulus 2 is not equal to 0, meaning it's odd. But if it's over here, if it's not true, then that means that number is equal to 0. This is a case where the remainder based on this modulus is not 0, and if not 0, it's odd. So the pocket is red for odd numbers over here. Else means that if it's not equal to 0, okay, right? So for example, I'm trying to explain this just so it's clear. All right, so if the user pocket number, okay, modulus 2 does not equal to 0, then that means it's odd. But if it equals to 0, if it's equal to 0, then that means that number is even, right? So else means that it's equal to 0. The user pocket number modulus 2 is equal to 0. Or you can go ahead and explicitly state that if user pocket number modulus 2 is equal to 0, you can go ahead and do that. But if this is not true, if the user pocket number is not equal to 0, the opposite of that is that the user pocket number modulus 2 is going to be equal to 0. Okay, all right. So else, or just to be clear and just to be explicit, let's go ahead and state it. All right. So I'm not going to use else. I'm just going to go ahead and do that. So I'm going to say else if user pocket number modulus 2 is equal to 0 this time, Then let's go ahead and print. The pocket is, okay, so for even numbered pockets, so this means that the number is even because any number modulus 2 gives you a remainder of 0, okay? All right, so any even number modulus 2 gives you a remainder of 0, so that means that number will be even. And for even numbered pockets for 1 through 10, the pockets are black. So in this case, let's say the pocket is black, right? So pocket is red for odd numbers, okay, and odd numbers divided by 2 gives you a remainder not equal to 0. Even numbered pockets are black, okay, because an even number, and the way we test to see if it's an even number is an even number modulus 2 always gives you a remainder of 0. So that's how we check to see if that number is even. All right, so now we are done in that range from 1 through 10. We've figured out which one is. We figured out if that number is even or odd. And we're going to display the appropriate color. All right. So if that user number, okay, the next range, okay, it's from 11 through 18. So over here again, we've ruled out the fact that that number is less than 0 or greater than 36. We know that number is not less than 0 or greater than 36. Over here, if the program bypasses this and doesn't run the statements in this if block, then that means that we've ruled out that the number is 0. So now we are working with numbers 1 through 36. If that number is not less than 11, then that means we are working with numbers 11 through 36, right? But over here it says 11 through 18. So after this LF, we're going to create another LF. Oops. We're going to create another LF right under this this block, okay? Okay, right after this, or this block, or under this block. So LF, because these blocks are the ones that are checking the range of the number, or what the number falls within, okay? All right. So LF, the user pocket number. All right. Again, once we know that that number is not less than 11, then that means we're dealing with 11 to 36. But we want from 11 through 18, right? So we want the numbers 11 through 36 that are also less than 18, right? So if user pocket number is less than 18, right, then that means we know we are dealing with numbers 11 through, it's less than 19, not less than 18. Okay, if we say if user pocket number is less than 19, then that means we are dealing with numbers 11 through 18, right? Because 18 is less than 19. But we know that once we get to this point, we're dealing with numbers 11 to 36. And for the numbers 11 to 36, we want the ones also less than 19. So that means 11 through 18. And that covers this range. Now, in that range, the odd numbered pockets are black and the even numbered pockets are red. So let's copy this block here, because this block was what determined if that number is odd or even. So I'm going to go ahead and paste it in this LF block and indent this well. So if the user pocket's number is a modulus 2 is not equal to 0, then that means it's odd, right? That means it's odd. And in that range, 11 through 18, the odd numbered pockets are black. So let's change this to black. And the even numbered pockets are red. So let's change the even numbers to red, because this is just a way to check to see if that number is even. Because any even number modulus 2 is equal to 0. So we'll know that. All right, so the next range is from 19 to 28, right? Once we bypass this range, okay, which is 11 through 18, if that number is not less than 18, all right, if that number is not less than 18, then that means it's from 19 to 36, right? And for the numbers 11 to 36, right, we want the numbers less than, sorry, hold on one second. Once we get to this point, once we get to this point, in this point, at this range, we are working with numbers 11 through 18. If that number, okay, we're working with 11 through 18. If that number is not 11 through 18, okay, if that number is not less than 19, then that means we're dealing with numbers from 19 to 36, okay? And for the numbers 19 to 36, we want the ones over here, we want the ones less than 29. All right. So for numbers 19 to 36, we want the ones less than 29. So if the user pockets number is less than 29, all right, that means we're dealing with numbers from 19 to 28, right? Because 28 is less than 29. And over here, we know that if that number is not less than 19, that means it's 19 to 36. But for that range, 19 to 36, we want the ones also less than 29. So that leaves us with 19 to 28. All right. In that range, 19 to 28, the odd numbered pockets are red and the even numbered pockets are black. So let's go ahead and copy that same if else block, and then paste it in here just to figure out which what color is for odd pockets, and what odd numbered pockets, and what color is for an even numbered pocket. Space this out a little bit. All right, so in that range, 19 to 28, the odd numbered over here, the odd numbered pockets are red and the even numbered pockets are black. So odd numbered pockets are red, okay. Even numbered pockets are black. All right, so it looks like it's similar to this one. All right, and lastly, we are dealing with the range 26 to 36. All right, so over here, if that number is not less than 29, right? Now this wasn't correct. I think that this is not correct. Let me check the range. I have the question here open, copied. All right, so yeah, see, it's not correct. I put in the wrong number. So for pockets 29 to 36, okay, that's the next one. All right, 29 to 36. So let me fix that. This is not, because it doesn't make sense. 29 to 36, okay, just to confirm. That's the last one for pockets 29 through 36. All right, over here. All right, so that's the last one we have to work on. So I'm going to create an LF just to get it ready. So if that number is not less than 29, all right, then that means we're dealing with numbers 29 to 36, all right? So we can even go ahead and do else, right? And we know that else is anything that falls here, the program gets here, we're dealing with numbers 29 to 36, because if that number is not less than 29, then that means it's not less than 29, okay? If it's not less than 29, then that means it's 29 and above. But it's not just above 29 to 36, because we've already ruled out numbers here, and even in the input validation over here, we ruled out the fact that that number is greater than 36. So we know we're working with numbers. By this point, we know we're working with numbers from 1 to 36, right? And over here, we've ruled numbers all the way down. We've ruled numbers all the way down. If we get here, right, and that number is not less than 29, that means we're dealing with numbers 29 to 36. So we can just call an else and print something, because we know that number will fall between 29 and 36. Or we can explicitly state that the range is from 29 to 36. All right, so we can do that. So if that number is not less than 29, then we know it's from 29 to 36. We can go ahead and do that, but I'll stick with else. If we wanted to stick with being specific and doing it yourself, you can say elif, okay, elif user pocket number, okay, is greater than or equal to 29. Okay, it's greater than or equal to 29, because we're dealing with 29 to 36. So it's greater than or equal to 29, and at the same time less than or equal to and at the same time user pocket, not you can't just type the number like that. So if user pocket number is greater than 29, and at the same time user pocket number is less than or equal to 36. Now this will fall in that range, because if that number is 30, that 30 is greater than or equal to 29. At the same time, that 30 is less than or equal to 36. So that will work. So we can go ahead and be explicit about it and type it this way, and then be very clear about the range. Or like I said, if you just delete this and you just call an else statement, that number is going to be in the range from 29 to 36, because we are working with numbers from 1 to 36, and we've ruled it, or we've trimmed it down over here. We've narrowed it down, okay, to For example, when we get over here, we know we are dealing with numbers less than 29, right? So if that number is not less than 29, then we know we are dealing with the numbers 29 to 36, because we know that's the range we're working with, okay? 29 to 36. So if that's the case, let's see what's happening over there. If for pockets 29 through 36, the odd numbered pockets are black, all right? So that means we'll need this test to see if that number is odd or even. So else, I'm going to create the colon, and I'm going to paste it here. Oops. And all right, so it says the odd numbered pockets are red. So so this is red, and the even numbered pockets are black. All right, so this is how to check to see if it's odd, and this is how to check to see if it's even. All right, so we're done with all the ranges, and we've done the input validation. And by the time the program runs, it's going to tell us if the pocket is red or black, and we'll cross-check to see if it's correct or not. So let's test this program to see if it's working. I'll debug it, but I have to save it first. So I'll save it in the folder where I store all the Python files. My computer is a bit slow. All right, so it's on desktop. Again, I forgot to put this in this folder. All right, it's fine. I'll create a new folder and I'll call it exactly the question: roulette wheel colors. And I'll create it, and then I'll save this as the same thing: the pie roulette wheel colors. The pie. Let me save it. Let's see what happens. Okay, we have an error, and it says over here syntax error. So let's see what I did over here. Alright, so if this is the case, then do that, else use a pocket number. Okay, so let's take this off so I can see it clearly. Alright. Just give me a second, I'm just going through this just to make sure it's good. Oh, okay. All right. So remember, I was trying to explain to you that we can just go ahead and do and write an else. Remember, I didn't realize this because I was just copying and pasting. So remember, I was explaining to you that over here, if that number is odd, right? There are two ways. If the remainder of this is not 0, okay, that's the first case. The other case is if that remainder is 0. So we can remember, I was saying that if that remainder is not 0, then the other case will be the remainder is 0. So that's why I was saying that if you just type in else without typing this, right, it will know that, okay, it will know that if that number, okay, was not 0, if it's not 0, then this is going to run. But if that number was 0, then that'll be the other way around. That'll be the opposite. So else, then you can go straight ahead and print the pocket is black. But you can, I was also trying to state that you can we can be very clear and explicit, and then state it ourselves, right? And when I was trying to show this example, I forgot to change this else to LF, right? So if this is the case, then print this. If this is the case, then print this. But I forgot that. If we're using else, then we don't have to type this. We don't have to type this whole thing, because again, else means that first we're checking to see if that number is odd. We're checking to see if the remainder of that number divided by 2, okay, of that number modulus 2 gives us 0. We want to see if that number not divided. We wanted to see if that number modulus 2 is not equal to 0. And if that's the case, then we're going to print the pocket is red. The other instance, okay, the opposite of that is if that number modulus 2 is equal to 0. So that's else. Else is the opposite part of it. So if that's the opposite part, if that number is equal to 0, all right, then the pocket is black. Okay, then do this. But like I said, we could have explicitly written ourselves, and that's what we're trying to do. But I forgot to. I'm going to undo this. I forgot to change this to LF. If you're trying to state it yourself, then you have to use LF because you are trying to type another condition. So I'm going to change all of these to LF. If you want to stick with else, then make sure you delete this because the opposite part of this, okay, if that number is not equal to 0, then that means it's odd. But if that number is equal to 0, then that means it's even. So else is the opposite part of it. Else is the opposite part of that number being equal. That number being equal to also the opposite part of that number not being equal to 0. Because if it's not equal to 0, then that means it's odd. But if it's equal to 0, then that means it's even. So else is the opposite part of this. Okay, this is the odd. All right. I hope it's clear. So for me, I'm going to stick with the elif and writing ourselves clearly. But I have to use elif because I'm typing in another condition. So elif here, and that should fix it. Okay, so I'm going to debug it again and see what happens. All right, so it looks like it works. So please enter a pocket number. Let's check the validation. I'm going to enter -4 and then hit enter. It says please enter a number from 0 to 36, right? Before that, I just want to space this out a little bit before I print out anything. So this is the question. Before I print out anything, I'm going to just call the print function with nothing in there, and that's just going to create a new line. Now, if you type the print function and you type in stuff like this, it's going to print this stuff here, but it's also going to take the cursor to the next line. So anything that follows this this string, it's going to display on the next line. But if you remove this, you call the print function without passing anything, it prints nothing, but it also still takes the cursor to the next line, and anything that follows this print statement is going to display on the next line. So what this does is basically it creates a new line. It creates an empty line with nothing printed in there. So we can have some kind of clarity or some separation between these two. So I'm going to debug this and then type in -67 to test the range of this and hit enter. Now it says now we have our new line, and it says please enter a number from 0 to 36, right? So that means it's working. I'm going to run this again and then type in a number greater than 36, which is 50, right? And hit enter, and it still says please enter a number from 0 to 36, right? And I'm going to test it with a valid number this time. I'm going to enter a number from 1 to 36. I'm going to enter 4 and then hit enter. Now it says the pocket is black. Let's test to see. So 4 falls in this range, 1 through 10, right? 1 through 10. So 4. So in the range of 1 through 10, the odd numbered pockets are red and the even numbered pockets are black. 4 falls in 1 through 10 and it's even, so that means it has to be black, right? So let's test a number in this range, 11 through 18. I'm going to enter 15, hit enter, and it says the pocket is black. So let's check to see if it's true. From 11 through 18, right? I entered 15. 15 falls in 11 through 18. The odd numbered pockets are black and the even numbered pockets are red. So the odd numbered pocket 15 is odd, so it's black. It has to be black. All right, let's check 19 to 28. So 19 to 28, I'm going to enter 21, okay, and hit enter, and it says the pocket is red, right? So let's check to see. From in the range 19 to 28, I typed in 21. The odd numbered pockets are red and the even numbered pockets are black. So because 21 is odd, the number has to be red, and it's red. It's correct. So let's check the last range, 29 to 36. I'm going to enter 30 and hit enter. It says the pocket is black. So 29 from 29 through 36, I entered 30. The odd numbered pockets are black and the even numbered pockets are red. So I think we didn't do that well. Let's check the question to see. So the odd numbered pockets are black and the even numbered pockets are red. Okay, so for numbers 29 through 36, which is over here, the else part. Okay, if the pockets, so the odd numbered pockets are, okay, so this is the odd numbered pockets, and what does it say? The odd numbered pockets are black. Okay, so we didn't change it. So this is in that range. This is what it's checking to see if the odd numbers, if the number is odd, and over here it says the odd numbered pockets are black. So if it's odd, then the odd numbered pockets are black. We forgot to change that, and the even numbered pockets are red. This is the number checking to see if it's even. Okay, if that number divided by 2, or if that number modulus 2 gives you a remainder of 0, then that means it's red. Okay, even numbered pockets are red for 29 through 36, so the pocket is red. So now let's just try the same thing again. So 30, let's check, pocket is red. Let's check to see 29 through 36. The odd numbered pockets are black, right? And the even numbered pockets are red. 30 is even and it's red. So this program works. Input validation works. If you have any questions at all, please comment in the comment section, and I'll do everything to respond to them. Thank you very much for watching, and I'll see you next time with the next program. All right, bye-bye.